Hi, everyone, and welcome to the very first episode of our podcast, AI Agents 101. I'm Mina, and I'm here with my co host, Jawad. Jawad, would you like to introduce yourself?
And thank you, Mina. Hello, I'm Javad, and I'm a student of generative AI, and I'm super excited to talk about agents today, and especially what we've learned about them.
Thank you, Joad. And for today's agenda, we're going to cover the following topics, including first, what are AI agents, and then talk about agents slash agentic workflows and what are their differences. Next, the historical evolution of what made agents possible. Then, why do enterprise agents actually matter? And last but not least, how to build agents. And let's get right into it. So, first of all, what are AI agents? I like to think of them as very smart coworkers. And not only do they know how to research things, where to find stuff, but can also complete their work like filing reports and scheduling meetings. And most importantly, they can think on their own and don't always have to ask what the next step is.
Yeah, and there are a couple of definitions that I've seen which I think are really interesting. So I'll start with the first one, which is a functional definition of an AI agent. Essentially, that they are digital systems that can solve multi-step complex problems, and they do that by breaking the task down, planning their next steps, and then reason on whether those steps make sense, then orchestrating or executing those steps, and finally learning from feedback. And they can be triggered either by a human in the loop, so a human asks them to do something in natural language, or they're triggered by the system. That's one definition. There's also the architectural definition of an AI agent where you can think of LLM at the center, and that LLM, a large language model, is then augmented by memory. It can use tools like calculators, and it can access external information via APIs, and it can work with other agents. There's also an interesting point of view that I'd like to add. It's not strictly a definition of AI agents, but I was looking at this YouTube video by Andre Karpathy, and he defines the evolution of software as in three stages: software 1.0, 2.0, and 3.0. Software 1.0 being really rules heavy, like you have to define the all the cases and all the conditions and all the rules, everything has to be coded. Software 2.0, where a lot of these rules are actually replaced by machine learning, so data and weights become more important. And software 2.0, he says, ate software 1.0. More and more of the code base started looking like, data and weights. And now
Mhm.
he's talking about software 3.0, which is essentially programming the LLM in natural language, in human language or English. And now more and more code will be written this way, he expects. And
Mhm.
when you look at an application, part of it will be written in software 1.0, software 2.0, and some of it will be in software 3.0. And I think agents is an example of such applications because they are working with LLM, they are augmented LLMs, they get natural language instructions. They have access to tools external to them, which could either be software 2.0 or software 1.0 tools.
Mhm.
So yeah,
Mhm.
these three definitions I noted that I really liked, which I think are relevant to AI agents.
Yeah, thank you, Joanne. Those are really, really interesting definitions. And we're definitely entering an era where there's more software 3.0 coming up. And just to give some examples, as you also mentioned before, agents can also run multi-step workflows and update their strategy on the go. And you usually will use agents when the problem is more complex, when it's unstructured and involves multiple steps. For example, something off the top of my mind is that when you're planning a trip, when you want to plan a trip with different possibilities, or you can use AI agents or instances when you're trying to figure out some open-ended problems. AI agents are a great use case. Okay, on to our second part. Joad, you also touched a little bit on agentic workflows, and it was a little confusing for me at first. What is the difference between agents and agentic workflows?
I really like Anthropic's article on the subject, and I would invite everybody to have a look at it. That's where I think the best definition of this difference comes from. Essentially, they'd look at it as a spectrum, where they call the spectrum of agentic applications or agentic AI, where on one extreme you've got workflows, a very stringent, predefined flows, um, uh, supplemented by LLMs. But on the other hand, you've got agents whose path is not predetermined. And agentic
Mm-hmm.
applications can lie anywhere on this spectrum. Um, I think, yeah, that there are a couple of definitions of it that we can get into in more detail. But the general difference is, the general definition is that agentic AI is a spectrum where on the one hand you've got very rigid workflows, and on the other hand you've got fully autonomous AI agents.
Mm-hmm. Thank you for that. And then I would also like to give an example. You can think of agentic workflows like a train. It's on a very fixed track, and you already know all the stops that it's going to stop at. And then for AI agents, you can think of it more as a self-driving car. You can choose the best route while you're driving based on the traffic at that point. And another really useful example in work could be a chatbot that receives an email and autonomously logs it, sets a meeting, and sends a follow up all by itself. And this is an AI agent because it has autonomy. And on the other hand, thinking of an agentic workflow, it could be an email being passed through a summarizer, a tool, and then an entity extractor, which is also another tool, and then a logger. So each step is predefined, and the agent kind of does not do any critical thinking on each step. So it has a workflow automatically logged out.
Yeah, that's a really good definitions, yeah, to drive the point home. And maybe I would take a moment to go through the different patterns of agentic applications that the blog lists. And they are by no means the only patterns that are possible. And of course, you can mix and match them. But I think having a general understanding of these patterns is quite good if you're looking to build agents. So the first pattern that they talk about is a workflow pattern, and it's a prompt chaining pattern, where basically the output of one LLM call is fed as input to the next LLM call. Our ChatGPT application uses that pattern in the background. Then there's the workflow routing, which classifies an input and directs us to a special follow-up task. Which are so, for example, if the first LLM, let's say, process is making a distinction between a different kinds of customer tickets, and then depending on the type of the customer ticket you want to take on follow-up steps, this would be an example of routing. So it basically routes it to the right, following steps. Then you've got parallelization flow pattern, and it has two different variations. One is what they call sectioning, and the other one is called voting. The sectioning is basically breaking a task into independent subtasks that run in parallel. So, example could be if you have got to do research on three different topics, you could break the task down to those three different ones and then do your research. And voting is running the same task multiple times to get diverse outputs. So basically, um, you're executing the exact same tasks multiple times to see if any, different result comes. It's really good for reviewing code for vulnerabilities. Then you've got the orchestrator worker workflow pattern, where basically you've got a central LLM which dynamically breaks down tasks and delegates them to worker LLMs. And then when the worker LLMs are finished with their tasks, the orchestrator synthesizes or summarizes their results. And the key difference between parallelization pattern and this one is that the parallel tasks are not predefined in this case. And you can see that this is already a little bit more agentic. right? So we're giving more and more autonomy to the LLM. Then you've got the evaluator and optimizer pattern, where one LLM call generates the response, while the other one provides evaluation and feedback in a loop. So this is essentially a loop of doing a task, getting it reviewed, and then improving it again, and then you can run it n number of times.
Mhm.
And then finally, the pattern, agent pattern, where LLMs are using tools based on environmental feedback in a loop until they get to their desired outcome.
Mhm.
And it's crucial in this case because the agent selects the tool autonomously. So it's crucial that the tool sets and their documentation is done clearly and thoughtfully.
Mhm.
So
I
these are the
see.
patterns. These, and as I said, they can be mixed and matched. They can be combined.
Thank you so much, Joad, for that detailed overview. So, we learned a lot about what AI agents are, the agentic workflows, and the different types of workflows. So, on to our next section, we have a special timeline lightning round. So, we want to understand what made these fascinating AI agents possible, and I'll try to explain everything in a minute. So, first, around the 1950s, there were basic predictive models, and then they evolved into machine learning systems that could find patterns in data. With the breakthrough of deep learning in 2012, it then enabled tasks like image recognition and language translation. And then deep learning also unlocked computer vision. So now our phones can all recognize our faces and unlock the phones. So then with foundation models like GPT in 2022, AI learned how to understand and actually generate human language across a wide range of subjects. So it can actually learn different topics. Conversational AI was further built on this to allow natural language so chatbots can feel natural. And this really powered areas like customer support. We have virtual assistants and also some interactive learning tools. And now, today, AI agents is the hot topic. So, our AI coworkers can actually plan, execute, and adapt to entire processes with minimal human prompts. So, with AI evolving so quickly, we really don't know what's happening next, and there has been a lot of conversations on the future direction.
And it's interesting that you say that. We almost will begin, I imagine, to look at these agentic co-workers as part of the workforce. And I also see that some of the terminology around resourcing has changed, where we used to previously call the human capital or the human workforce, and now we're just using the term workforce. So that
Mhm.
shows you how the paradigm is slowly shifting, and then the workforce is no longer just human workforce. It's a combination of systems. It's a combination of humans, as well
Mhm.
as robots, as well as AI that drives them.
Mhm.
I also want to talk about why, like, what is the significance of agents to businesses and enterprises, right? So I mean, we've been talking about use cases like, okay, if I want to book a family vacation, I just give it some instructions and it goes and books everything for me. But we have to talk about also why this is important for enterprises. And I think productivity is and leverage are the two words that come to my mind. There was a recent report by BCG which said
Mhm.
that compared to generative AI, which generative AI has already shown results in terms of increasing productivity, the
Mhm.
article said that compared to generative AI, agents are supposed to deliver 3x more productivity. So
Mhm.
that's a huge jump already, and we're just at the beginning, at the start of this this revolution or evolution of LLMs. Um, and I think the real value in that article, it said, comes from cross-enterprise collaboration. So I do believe that is the value proposition for enterprise. It's having leverage on the human workforce and also having leverage on their data sources. I
Mhm.
mean, let's talk about human resources first. As I said, it's already been shown that the productivity of the human resources increases dramatically with access to AI tools. I mean, you must have heard the now cliche saying that, AI won't replace you, but somebody using AI will. I think that's very much true because people are becoming super productive and super creative with access to these tools and compared to somebody who doesn't use them. Um, there's of course the initial education and training effort from the enterprises that will have to go into that to use AI properly and safely and ethically. But I think the ROI is huge.
Mhm.
Um, and now let's also talk about data. So if the quality of your data is good enough, you can actually rely on AI agents to not only automate some of your routine processes, but also help in decision making. If your data is good, AI agents can analyze that and actually help you with making business decisions. So,
Mhm.
decisions that require days of analysis, of preparation of data, they can actually be in terms of time, uh, reduce the effort significantly. So those are the two ways I think enterprise can unlock the value of AI agents, and that's why everybody's so excited about that. So the question now becomes that what is a good use case if you're building AI agents? The first thing you have to do is to identify a good use case, and how do you identify a good use case? Just because you can build AI agents doesn't mean that you should. So from research, we learn that there are a couple of criterias that a use case should satisfy. I mean, one, is the problem that is being solved really a pain point or a bottleneck for the business, right? That's number one. Um, Number two, is it a repetitive, low value task that you think can be automated by an agent or robotic process automation? Then it is a good use case. Um, can you clearly describe the work? Because if you cannot clearly describe it, you cannot, at this stage at least, you cannot expect the agent to come to the desired outcome. You need to be able to describe what the problem is and what the desired outcome you need. Um, and then also, is this something that is better suited to a workflow? So is this something that should be like predetermined rather than letting the agent figure out what to do? Because with agents, the results are probabilistic. It's not always going to determine, it's not always going to behave the same way. So if there is something that requires a very stringent series of steps that should and rules that should not be violated, then perhaps AI agent is not the right use case for that. Then there comes the question of readiness in terms of data. Do you have the data? And do you have access to the systems where the agent should be performing this task? So the quality of data and access to the system is hugely important, and that's the number one challenge of enterprises when it comes to deploying productive AI use cases. Then there are other elements like scalability, and also very important. Is the agent operate is the agent operating within the legal ethical framework of your country, your organization, and then finally, is this actually generating some business value for the business? Right. So, as I said, all of these criteria help you decide. Just because you want to make an AI agent doesn't mean that you should. You should analyze the use case thoroughly against these dimensions and then go ahead and try to deploy an agent.
Yeah, thank you, Jawad, for that. And then once we have identified a good, really good use case, and then we know that we already have enough like clean and very structured data so the agent can operate on it, we want to really understand the agent's access to data. I think data is always, always a very important topic because there's also another saying that your AI is only as good as the data it gets. So the issue that we really want to avoid is that agents often get access to either too little data, so they can't perform their job properly, or too much data that it actually might become a security risk. For example, you can think of personal identifier information or like internal legal documents or financial documents. So you want to feed your agent really clean, governed, and data that fits its goals. And you also want to make sure that the agent only accesses what it's supposed to see. So, in addition to techniques like RAG, knowledge graphs, which we'll touch on later, and also vector search and so on, you'll also need first very secure API access. So, the agent should never access raw databases directly. And second, you want to limit its data access based on the roles to ensure the agents only access data within their scope. For example, a customer service chatbot cannot access HR files, and an internal HR agent cannot pull information, for example, from legal cases. And the third thing is that you want to block storage and recall of sensitive data. For example, if you have a chatbot, it cannot store any sensitive information from the chatbot, and the chatbot might temporarily reference a user's account balance during the session, but after the session, it is strictly prohibited from storing it for reuse or training purposes. And fourth, we want to encrypt the data in transit for all the communications. So even if we have, like, for example, intra-cloud communications between your AI layer and your ERP system, it should all be encrypted.
Right. And so those are the two things, right? So one is to build agents for the enterprise, you have to have a use case. Number two that you covered, Jasmina, is access to data.
Right.
Number three is understanding the business meta model, right? So for the agents, um, it's important that they understand the business jargon. It's also important that they understand domain-specific knowledge
Right.
as well as hierarchical relationship between entities and business.
Mhm.
So the way to solve that is, I mean, initially RAG is one way, retrieval augmented generation.
Mhm.
Basically, you provide the LLM with a particular knowledge resource. It's an intelligent way of providing additional information to the LLM without having to fine tune it, because fine tuning can be really, really expensive. So basically, what RAG does is that as soon as user enters a query, the query is searched against the provided knowledge base, and
Mhm.
then using similarity search, specific components of that knowledge base are selected and then passed into the context along with the user query, and then the LLM is able to make sense, essentially answer the question from the context. Um, but there are some issues with simple RAG. As I said, it's not able to understand the relationship between entities,
Mhm.
even though it's very cost effective, as I said, as opposed to fine tuning. And it's really popular. It is still very useful for certain use cases. It cannot connect the dots, and it cannot develop holistic understanding, right? It struggles to traverse, disparate pieces of information and the relationship and the associations between them. And it also performs poorly when it is asked to summarize semantic concepts over a
Mhm.
large body of data.
Right.
So that's where the other element of, let's say, context engineering comes in, which is called knowledge graphs. And graphs have been there for a long time. And graphs are essentially databases that store relationship between two entities. So it's
Mhm.
basically object one, object two, and the relationship between them, and that's stored in the database. Graphs can be really useful and can complement the existing RAG process. We call it graph RAG now. And the good thing is you don't need to develop these graph databases from scratch. You can actually use LLMs to generate your graph databases and then can later use them. So it's pretty interesting and pretty neat, but it is one way of educating the business, educating the LLM about the business.
Mhm.
So yeah, this was the third element. So first element, having a use case, second, access to data, and then third, understanding the business meta model and having domain specific knowledge.
Okay, thank you, Joad. And now on to our fourth element, guardrails. We want to chat about what are some guardrails that you need to implement. So what if your agent can save sensitive data and use it to generate misleading outputs? That's the worst nightmare someone can imagine. So, and with the power AI agents have, enterprise must set boundaries. So we must limit information like what agents can access, the actions they are allowed, and when to escalate to humans. So there is a model content protocol framework that is really useful in defining a structured boundary for AI outputs. It defines what kind of outputs are allowed, what formats they should follow, and what guardrails need to be enforced. It's kind of like giving your AI agent a playbook and a leash at the same time. So there are many things that you can specify with this framework. For example, just to name a few, you can have automatically filter PII, which is personally identifiable information. So, for example, a customer support agent might receive a message that the client's credit card is, for example, 1234, and the agent should redact it before processing or logging the input. Or their credit card information might be used as training data for the model and it might be leaked in the future. So, we want to avoid that. Related to that, you can also redirect any sensitive response to a moderation layer or a human. For example, if the agent receives any tasks involving sensitive financial disclosures or legal information, the agent must escalate it. So you can set that as a guardrail in advance. And also, another very important part is action permissions. So, we want to define what actions the agent can and cannot take autonomously. For example, you might set that for a legal agent, the agent can draft the contracts, but only the human can sign them and then send them out to partners for them to sign. And you can also specify some output schema definition. For example, specify only output formats like a JSON file or a Markdown file, etc., suitable for the use case that you have. And last but not least, you must have a factual validator to cross-reference with internal sources to ensure that the agent is not hallucinating and not giving you the wrong output.
Yeah, and very closely related with having guardrails is evaluation. So, as we said before, LLMs are probabilistic systems. So, agents are by definition, if you leave them to act autonomously, they are probabilistic, and that's why you have to have some thorough testing done on them. We call them evaluations or evals. They're different, more complex, I would say, than just unit testing for traditional software. So, if you're launching an agent without knowing if they actually will solve the task that you want them to solve, and then not comparing them against a human benchmark, and then what are the patterns of their failures without knowing that, your agent essentially is not ready for production, right? So so that answers the questions of why you should evaluate your models. It's because you need to get visibility. The evaluation framework gives visibility of what your LLM or model is capable of. Sorry, the agent is capable of and what it's not able to do. And different capabilities require different approaches to evaluate. For example, if let's say you're building a trade compliance system, you will need accuracy, you will need knowledge of compliance rules to be tested. You will have to consider cost. You will have to test for efficiency, accuracy, suitability, etc. And then, of course, you have ethical and regulatory requirements as well that you need to evaluate. And that's why you need evaluations. And evaluation is not a process that is done once and then you release your agent into the wild. It's actually a continuous process because LLMs change, they evolve, user expectations change, and you would want your agent to be relevant, for a long period of time in your business. And for that, you have to continuously evaluate and improve it. Um, And by the way, when we think of an LLM application, there are multiple touch points. So it's not only the prompt that we have to test, and then the outcome of it. There are multiple things. We have to go down to the level of how are the embeddings generated in your application? How is, especially in the RAG process, how is information re-ranked when it is added into the context, passed into the context? And then the prompt construction, of course, and then what the LLM response is. And there are different frameworks out there that help you test, evaluate your LLMs. I would not go into all of the detail of them. I very much encourage everybody to search for offline or pre-production model evaluation as well as online model evaluation. But just say that, just keep in mind that there's part of it that you do pre-production, that's the offline part, and then there are parts of it that you have to do post-production or while the agent is actually running in the productive environment.
Okay, thank you, Joad. And so we went through a lot of information today. And before we wrap up, we want to leave you with some really useful tips. So, some tips that I have is to keep the designs very simple, as we also touched upon a little earlier. We want to really think about whether if you need an AI agent to complete our task or if it can just be done by a simple query. You don't want to overcomplicate yourself when designing things. And the second tip is when designing the workflow, you want to ensure that every step in your agent's process, the agent should do something meaningful. Either it's completing a task or triggering another step or escalating something. Otherwise, you might have an over engineered loop that doesn't really go anywhere and the agent gets very confused. And the third tip is to be transparent. You want to let your users see what steps the agent is actually taking. And for example, we can see sometimes when you ask ChatGPT something, before it gives you the actual response, you can see that it's thinking and you can see the step by step thought process that's going through. And this really makes it way easier for you to also debug it later. For example, when it has a bug like booking a meeting at 3 a.m. And the fourth tip is to not assume everything will go well as planned. So you can think about what happens when the agent gets partial information, really weird user inputs, or tool errors. And you want to build for these edge cases early on through a lot of testing and make sure you test them as thorough as possible. And those are some of the tips that I want to share. Joa, do you have any other tips for us today?
I think you covered everything really nicely, especially the point about transparency and explainability. It has to be embedded into the system. Otherwise, you will not be able to tell what's going wrong, and then, it will be very difficult to then evaluate your model or your application exactly where it's going wrong. So, yeah,
Mm,
just will double down on that point.
mhm,
Um, I would also say think about the big picture, right? What you should improve as AI models get better. I mean, everything has to be at the end of the day measured on the scale of what capability and benefit it provides to the business. Technology will keep on evolving, and it's important to know where you want to take your enterprise, where you want to take your business before
mhm,
you supplement technology in your organization. Um, and I will also say that documentation is really important. Once these systems go live, maintain documentation. That
mhm,
would be your best way of understanding what these agentic systems do and
mhm,
where you need to make improvements. It's almost like, you establish a discipline of LLM ops, like DevOps.
mhm.
Um, so yeah, those would be my five, a few more tips on top of what you've already covered nicely.
Perfect. Thank you, Joad. So that is everything we have on our agenda today. We hope this podcast has been somewhat informative for you. And we also have a next episode coming up on another critical part of AI, which is context engineering. And before we finally end off with this episode, we want to end this off with a question or a call to action for you. So really think about, what possibilities do you see AI agents to transform the way that you work or live? It could be automating tasks or your team's workflow or in your personal life. If you have to have a file that you regularly download or an email that you regularly send, automating this process could not only save you a lot of time for this case, but it can also help you to scale that process in the future. And yeah, thank you so much for joining us today. Do you have any last words, Joad?
Yeah, I would love my agent to attend meetings on my behalf and then just summarize them for me at the end of the day. Yeah,
We all
and that's
wish.
yeah, no, thank you, Mina, for hosting this, and yeah, looking forward to the next one.
Yeah, thank you. Bye.
Bye bye.